Hi and welcome. My name is Patrick Lundqvist and today I will show you our LTE IoT demonstration. In this demonstration we'll be using our network simulator to show how an operator can add a large number of LTE IoT devices to its network without impacting existing smartphone user experience. So here we have 10 cell sites supporting over 50,000 LTE devices. Down to the right, we see that the network utilization is around 50%, which is a normal level for an operator to provide good user experience. So let's go ahead and add some LTE IoT devices. So here I'm now adding as much as 3.3 million IoT devices to this network. So you can see we're getting a pretty dense deployment going. What is remarkable that after adding all these devices, the user experience has barely changed. We see a difference from 4.11 to 4.07 megabit per second. So we haven't really impacted the smartphone user experience by adding this many devices. You can see that the network utilization went up 8%, and that of course means that the average throughput on an IoT device is many order of magnitude less than a smartphone. But still, we're supporting more than 1 million devices per square kilometers, which by the way is the IMT 2020 requirements for IoT, which means that LTE IoT is the initial massive IoT solution. So, what are these 3.3 million devices we added? We have 4 categories that you can see here. The first category is a category where we have a mix of eMTC and narrowband IoT devices. Here we have used utility meters as an example for this category, but of course there could be many other devices that fits into this category. We also can see here some of the differences between eMTC and narrowband IoT. First, we have the bandwidth. eMTC is using a wider bandwidth of 1.4 MHz, where narrowband IoT is using 200 kHz, which coincidental is the bandwidth of GSM. So for some operator who is interested in refarming GSM spectrum, narrowband IoT is an interesting option. Second, we have a higher order modulation for eMTC, which of course then translates to higher speeds. So eMTC supports up to 1 megabit per second speeds, where narrowband IoT is limited to less than 100 kilobit per second. We also see that we have voice and full mobility support for eMTC, which we don't have for narrowband IoT. But both of these technologies are designed to support battery lives above 10 years. The next category, where we see only narrowband IoT, we use streetlights as an example. We have 800,000 or so devices here in this simulation. In the third category, where we have only eMTC, we have using security panels as an example. So, the last category is wearable. So the first use case is downloads. So for wearable downloads, we can think of a map download before an application starts. So here we can see the effect of difference between the bandwidth in eMTC and narrowband IoT, how it would be experienced by the user. And as you can notice, there's a noticeable difference. So of course, eMTC would be a better choice for this use case. When we come to tracking, so eMTC supports handover and full mobility, as we can see as the seamless transition or communication of this line while we're tracking the mobile. The narrowband IoT has interruption, which is caused by not supporting handover and therefore has to use cell selection, which causes interruption. And in the last use case we're showing is music or streaming music, where we can see the difference of data bandwidth translated into narrowband IoT occasionally buffering. Thank you so much.